Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Haziq and my group members name are Ishraf and Hafiz. Today we would like to discuss about a topic minimum and maximum problems. So, as we know, minimum and maximum problem we solve by using the differentiations. So, I would like to define about the differentiations. Differentiations allow us to find rate of change. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on graph y against x is the gradient of the curve. There are a number of simple rules which can be used to allow us to differentiate many functions easily. So if y equal to some function of x, in other words, if y is equal to an expression containing numbers and x, then the derivative of y with respect to x is written dy over dx, but we pronounce it dy by dx. So, other than that, in a simple way, you can understand that differentiation is the derivative is the instantaneous rate of change of a function with a process of finding the derivative or rate of change of a function. Just to make you more clear, differentiations means to simplify, reduce a thing in its small thing to make a big thing in its smallest form in differentiation.
Assalamualaikum. My name is Muhammad Ishraf bin Hashim. So for today, I will talk about problem statement in our project. The main purpose of this part is to find and identify what the problem are difficulties that occur before do this research. Besides, this part can function as a guideline in develop the program that identify. First of all, apply differentiation concept on this project. So, we need to apply this concept to find out the maximum and minimum values that we need to create it, so that we can stabilize it, because at the same time, we want to create a bigger scale for a wedding program. Secondly, lot of mathematical equation. In do the analysis for the bigger scale, there are a lot of mathematical equation that need to use for a calculation process. Hence, if the researcher means the important equation are part of the mathematical equations, the calculation process will give wrong result to researcher, and this will make the analysis is fail in achieve the objective as mentioned. This is our project for today. Oh no, this is not our project. I remember that is not our project. So, okay, it's our real project. So what you can see here, you can see it has two cylinder, first cylinder and second cylinder. First cylinder have 2 HCM and the other one have 1 HCM, and it has 2 different radius, is about 2 RCM and RCM. So what you can conclude here is the first one is twice for the other one cylinder. So this is our design for our cake project. So let's continue with this question. Figure below shows a closed small cylinder that can with radius RCM and height HCM is placed on a large cylinder The radius of large cylinder is 2r cm and height 2 cm. So what we need to do here is we need to analyze what we need to do for the solution. So A, if the surface area of both cylinders are 315 pi cm squared, express hash in terms of arc. So what we need to do here is we need to analyze that hash in terms of arc. So B, show that the volume of both cylinder is given by V equal to 350 R minus 36/5 pi R cubed. So what we need to do here is we need to know how to apply the volume of cylinder. So first C, for the last one C, determine R in cm so that the volume is a maximum. Hence, find the maximum volume of both cylinder. So here you need to find volume. Of course, it will be V, biggest V. So here you need to find V max, V maximum. So let's check out for the solution. Plus 2 pi times 2r squared plus 2 pi 2r times 2r 2h equal to 350 pi. So here it will be 2 pi rh plus 8 pi r squared plus 8 pi rh equal to 315 pi. So is equal to 10 pi rh equal to 315 pi minus 8 pi r squared. So it will be h is equal to 350 minus 8r squared over 10r. So that's all.
So the question is, determine R so that volume is a maximum. Hence, find the maximum of both cylinders. So, firstly, from the equation is, we must differentiate into dV over dr. So the equation is 315 pi minus 108 over 5 pi r squared. So we must, from the equation, we must same equal to 0. So 350 pi minus 108 over 5 pi r squared equal to 0. 315 pi equal to 108 over 5 pi r square. So r is 3.82 cm. From this equation, we must differentiate again, and we get minus 216 over 5 pi r. Okay. When we want to find a maximum, B maximum, we must use a second derivative test. So r is 3.82 cm. When we substitute that this value into this, we get positive result. So that means V is a maximum. So how to find a volume maximum is we take this value into this. So 315 darab 3.82 minus 36 over 5 pi multiply 3.82 square. So we get 2519.4 cm cubic. Okay, so that.
To the B question, it asks us to show that V is equal to 315 pi r minus 36 over 5 pi r to the power of 3. First of all, we must know the formula volume of the cylinder. The formula is V equal to pi r squared h. But the formula for the whole diagram is V equal to pi r squared h plus h pi r squared h. So we have the h value from the h So this expression shown. So we go to the next question. It will be conducted by Hafiz.
So for the conclusion, when apply a maximum and minimum, we can identify the quantity to be maximized or minimized. We can apply the knowledge of derivatives in critical points in solving the maximum and minimum problems. Last but not least, we can solve maximum and minimum problems with ease and accurate result. So that's all.